Hey everyone, welcome back to our Calculus 3 class notes. We're working here starting in chapter 4. It's chapter 14. We're on page 43. And chapter 14 is about a topic called partial derivatives. So in section 14.1, we first need to talk about functions of several variables, which is likely something you haven't seen before. So first the definition, real valued functions of more than one variable. So suppose D, which is going to be our domain, is a set of n tuples of real numbers. So we often say, if we have a coordinate pair, we have x and y. If we get more than two, we don't say coordinate pair, we say a three tuple or a four tuple, etc. So let's say we have a set of n tuples. In other words, they're coordinates with n coordinates. A real valued function f on that domain D, wow, excuse my voice, is a rule that assigns a unique, in other words, a single, real number, w equals the function of x1, x2, dot, 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 out to x sub n, to each element in that domain. So the set D is what the domain of our function is. The range is the set of w values, right? All the values of w that are taken on by f. W is the dependent variable of the function. F is actually the function of n independent variables, x1 to x sub n. And the x sub j goes from 1 to n, so x1, x2, x3, etc. out to x sub n are the input variables. And w again is also the output variable. So the dependent variable is sometimes called the output variable. So examples of what we may see when we're working with the functions of two variables. So we may see something like this. Z equals the square root of y minus x squared. Okay, so what is the domain of that? Well, when it's asked for the domain, it's asking for the natural domain. So when you look at that and you see a square root, the first thing you need to think of is whatever's inside that square root needs to be positive or zero. So y minus x squared has to be greater than or equal to 0. Or we could say that's the same thing as saying that y is greater than or equal to x squared. I'll actually explain this a little bit on the next page, but so you kind of just imagine the function y equals x squared. And if y is greater than or equal to x squared, it could be every point on that parabola, y equals x squared, and all the stuff that's kind of inside above the parabola all the way out to infinity. So in other words, every place that y is greater than x squared would be sort of inside that parabola. So that's the domain. You can picture it in the xy plane, and then z is a height, depending on what x and y. It's a surface that lies above the xy plane. Okay, and then the range is, well, what values of z are taken on for all values of y and x that this is possible. Then z is just always positive or 0. So the range of z, that function, is from 0 to infinity, including 0. Then if I see something like z equals 1 over xy, so that just, I look at that and I say, what's a natural domain? The only thing that's a problem with this function if x times y is equal to 0. So our domain is such that x, y cannot be equal to 0. And if you think about what that is, that's all the points in the xy plane except the origin. Right? The origin is the point 0, 0. So if you plug that in, it's certainly 0. And then anything along either one of the x or the y axes. So because along the x-axis, y is always 0, and along the y-axis, x is always 0. So it's all points in the xy plane except the origin and along anywhere on the axes. Now what's the range of this? Well, the range of this is basically any value, except you can't have 0, right? If I have a constant 1 divided by something, that can never be 0. It can be any other value. X and y could get to be huge, where the 1 over huge number gets really, really close to 0, but it can never be 0. Then let's say you have z equals the sine of x times y. So if I take the sine of something, what's its natural domain? Well, whatever's inside of it can be anything. It's absolutely okay to take the sine of any value. So the domain of sine is minus infinity to infinity. So that means that either x or y can both go from minus infinity to infinity, which means it's the entire xy plane. Okay, now what's the range? So you have to understand, remember that the trig functions, sine and cosine, both go from minus 1 to 1. Well, that still will behave the same. So the values of z that we're taking on when I take the sine of any number will go from minus 1 to 1, including minus 1 and 1. Now what about if I have a function of 3 variables? So there's examples of function of 3 variables. Again, look at natural domains. So if I have w equals the square root of x squared plus y squared plus z squared, function of 3 variables now, well, I can plug any value essentially into this because x squared is always positive, y squared is always positive, z squared is always positive. So when I plug in any values for x, y, and z, this thing will always be positive or 0. I guess if x, y, and z are all 0 at the origin. But that's still the square root of 0, which is 0, so that's fine. So in other words, it's entire 3 space, all of the 3-dimensional space, x, y, and z. One way we write that, and we don't really write it this much in this class, but that's called R3. So you think of that, if you want, as real numbers in every direction along the x-axis, every direction along the y-axis, every direction along the z-axis. The space is called R3 at times. In our calc book, they just say it's 3 space. Okay? And then what's the range of that? Well, again, we're taking the square root of something, so the square root is always a positive or 0 value, so the range of this will be 0 to infinity, including 0. Now, what if I have w equals 1 divided by x squared plus y squared plus z squared? So again, the only time this will be a problem is if the denominator is 0. And the only way the denominator can be 0 is if I plug in the origin, right? X equals 0, y equals 0, and z equals 0. So this is all of 3 space again, except we can't include the origin. So you can say entire 3 space except the origin, or you could say XYZ cannot be 0, 0, 0. XYZ cannot be the origin. What's the range of this? Again, it can be, this will always be a positive number. So 1 divided by a positive number will always be positive. So it goes from 0 to infinity, except it can never quite be 0. Right? X squared plus y squared plus z squared can get infinitely large, but 1 over a big, big, big number approaches 0 in the limit, but it can never reach 0. Or what about w equals xy times the natural log of z? Okay, so x times y, there's nothing wrong with that. That's fine. I'm thinking natural domain. The only thing you have to worry about is the natural log function. You have to remember you cannot take the natural log of any negative number or 0. So this means that x and y can be anything, but z has to be greater than 0. So it's half of the 3 space, only where z is positive. So it's everything above the xy plane and not including the xy plane. But once we do that, the natural log function we know runs from minus infinity to infinity. So this whole function will run from minus infinity to infinity. So the range is minus infinity to infinity.